Physics chapter 17, theory, fourth video, angular velocity. So now they say the hands of a clock would steadily travel around the face of the clock, even though its velocity is constantly changing. Why does the velocity change? Because the direction is changing. But it travels through the same angle every second. The minute hand travels around 360 degrees or 2 pi radians. That is 360 degrees is equal to 2 pi radians. We learned that earlier. In 3600 seconds. Why 3600 seconds? We are talking about the minute hand. Minute hand takes 60 minutes to go around the full circle. That is to travel 360 degrees. So each minute has 60 seconds. There are 60 minutes in an hour. So 60 into 60 is 3600 seconds. The velocity is changing. Like I said, it is changing because of the change in direction. We can say that its angular velocity is constant because it moves through the same angle every second. Then angular velocity is measured by the equation angular displacement divided by time taken. We know that angular displacement is the delta theta or rads, how many rads does it change. Time taken is obviously measured in seconds. Then omega or angular velocity is measured in omega. Omega is measured in rads per second, right? Rads per second. So now if you take the angular velocity of this minute's hand of a clock, then it travels through 360 degrees, but we don't take it in degrees, we take it in rads. So that is 2 pi rad. 2 pi divided by the time taken is 3600 seconds, then we get 0.00175 rads per second. That is the speed of angular velocity, or rather angular velocity of the minute's hand of a clock. Let's write down a note on that. Angular velocity topic. Write down. The hands of a clock in relation to itself travels around the face of the clock at a steady speed within brackets, moves through the same angle, moves through the same angle in any given unit time. Close brackets. Despite its velocity constantly changing. Despite its velocity constantly changing. Open brackets and write, because the direction is changing. Leave a line, put a star and write down. Because they travel through the same angle, because they travel through the same angle in any specific unit time, we say that its angular velocity is constant. Right? Then write down the definition for, or the equation for angular velocity. Angular velocity equals angular displacement divided by time taken. Then omega equals delta theta divided by delta t. Then delta theta divided by delta t. Now we have to take the minute hand of a clock. So in a minute hand of a clock, we have it travels through 2 pi, because one whole circle is 2 pi, divided by 3600 is the number of seconds that it takes. Then you get 0.00175 rads per second. So please write an example and then write down for a minute's hand of a clock, omega or angular velocity equals 2 pi over 3600, and write the value. I hope you have understood. If you have understood, please do question number 5 and 6. I will discuss the two questions in the next video.